this is I'm doing a presentation on it's titled the Philly Green Roof Solar Tour. Originally, I was doing this for the American Solar Energy Society, and which was, I guess, virtual, and it didn't really quite work very well of having a virtual tour like that. But I was glad I had it kind of in shape to be able to provide a webinar on this. So I decided to tweak it up and work it out, and it really worked out well. So let's see, there we go. So this is going to be a presentation on 4 passive house design projects that were done in Philadelphia, and they're basically a mix of townhomes and multifamily buildings. 3 of them are over green roofs. These were all onion flats projects. And many of you probably know Onion Flats, a Philadelphia-based company. And Onion Flats, I find, has always been very unique. We're not only doing architecture, but they're really getting down into the dirt in their hands, doing the welding themselves. I mean, they really get really into it, which is fantastic. I've been doing all their solar consultation, design, and oversight, and some even installation aspects for over 10 years. And it's been great working with Tim McDonald and Patrick McDonald over the years doing these. They're very, very innovative and forthgoing with their ideas. I understand, I realized I had to show I think it was something about me displaying a mentor of mine. I don't know how many of you may have known of this guy, Steve Strong, who goes way back. When I started doing solar, I've been doing solar for about, I started about 40 years ago doing solar thermal work in the Carter days. Over the past 25 years, I've been doing photovoltaics. And at that time, there was really not anyone really doing any of that work around. I was relying on national folks to get information and learn, but I did a lot. I really learned a lot on my own, and I've brought that out to others as well. Steve Strong has been a champion for many years, an architect, engineer, and has done a lot of really innovative designs. And it was this book that really turned me on. I picked up his book that he put out. This was the first net metered net zero home that was built and designed, which he did back in the early 70s. I think, oh no, I'm sorry, in the I think it was very early 90s. I forget exactly when it was, but this book came out in 94. I read it in 95. Now, I've met Steve Strong several times over the years. In fact, I just happened to see him this August in Colorado at this agrivoltaics community solar farm, which is pretty cool. And if you don't know what agrivoltaics is, it's really having a ground-mounted solar facility. It could be several megawatts or whatever, but you're utilizing the ground as well for planting or grazing animals. So you're multi-purposing the land area, which actually has, of course, adds much more value to that. Okay, so I'm going to jump into this now. The 4 different projects I'll be going over: the Bellfield Homes, which is not a green roof type of project, but the stable flats, capital flats, and front flats are ones. And this happens to just be a little model. It represents either of these 4 projects, but Onion Flats or Tim or whoever always builds, of course, these models, I'm sure, as many of you architects do. And I just thought I'd take a snapshot of that and show this in that view. So talking about the Belfield right now, let's see. So this was 2012. This wasn't the first solar project that these guys have done, but this was one that really was one of the earlier passive house projects that they did. It's basically a row home, 3 row homes tied together, and it was modular built, and it was in fact the first certified passive house in Pennsylvania for row homes, if I got that correctly stated. It was a Section 8 development. So I think the intent of what Tim was trying to do was to demonstrate that you can build passive homes at like basically without added cost, basically at the rate for Section 8. I mean, it's hard to believe that you could do that, and that was successful. and we did have a PV on top of that. So these are about a little over 5 kW PV. These are horizontally mounted. And as far as I know, it's still in operation. This is a kind of a cool shot, I think, on a genie way up high in the sky. This was modular built, as I was saying. So it was built in a factory, and it was carted, of course, in its compartmentized sections. Created down its position, taped up and secured for reducing infiltration. These are, of course, classic triple glazed windows and everything else. These are completely electric buildings. This is the front of that building with the brickwork that was done afterwards. This was then this is where I come in with doing the installation on the roof. These are unistruts that are going. They're spanning across the parapets. And everything, again, is mounted horizontally. Of course, we're trying to minimize shading impacts from these vents from the ERVs. And yeah, so this is pretty much the completed job there. Now this is where I started to do some of the monitoring as well. In this particular, for all these projects, I did the monitoring for all these 4 projects. And this one, of course, started with the most monitoring. So not only were there are CTs for monitoring all kinds of electric usage on every circuit for these 3 buildings, but also temperature sensors and air quality sensors, like everywhere, in every room, all over the place. It was overkill with the data. It was like overwhelming. And I should just tell you that, you got to be careful with monitoring, because you get what you ask for, or maybe it's not what you ask for. You're going to get too much data that you don't know what to do with and how to analyze it. That really becomes almost a problem at sometimes. Unfortunately, we only saw this data for the first period of time when it was first installed, but it's been, of course, handed off to the owner of this project, and I haven't been able to get hold of any of this data since then. Moving on to stable flats. Now, this was also a row home, if you will, in construction, but it's 4 stories instead of 3 stories. And these were market valued systems, so they were sold to families. And these were pretty high-end type of row homes. This was intended to be a 70-unit structure, really development. But unfortunately, these 3 prototypes that were done initially, or preliminary buildings that were done initially, right around that 2008 economic fallout, so everything kind of fell apart at that point. And I think a lot of the designs were sold off to other developers after which. So at least we had these 3 buildings put in place. This was the first one where we experimented having the solar over a green roof, and it was pretty exciting to be able to do that. So these are about a little over 4 kW per townhome over that. And you can see that the solar is way up on top, again, flat roof, and we did the same thing, unistrut crossing over the parapets. Okay, so this is a sort of a quick drawing of that, and this is on the left side is facing south, and the north side on the right is where there would be a penthouse, although that actually wasn't built for this project. But you can see how we were trying to compromise with how far apart those rows of solar panels would be placed, and their tilt and inter-row shading, but also allow enough diffuse radiation to come through and to be enough for a green roof to flourish. And this is sort of this was a few years after that this system was all installed, but at least you could see some of that green roof is in fact intact there. And you can see that the unistrut is spanning across the parapets. I'm going to see if I can get this. Can I get the pointer? Oh, there it is. Okay. Yeah. So you can see the now what we had to do here was we had to really custom a lot of the hardware to be able to mount these solar panels onto this, and then to make sure it's rigid, and these and really make sure that there was little deflection on the unistrut. So here's another view of that. And this over here, you can see this is later on when the other developer built these structures. They did in fact put some of those penthouses there, but they didn't have I'm not sure how close they came to designing and building as close to the passive house that these were constructed originally as, and they certainly didn't have solar on them. And what happened here, you can see over here on the bottom right here, this again using Unistrut, all this stuff was welded and really assembled on the spot. It was a very impressive system where after looking at it a couple of years after, it was generating as much, if not better, or more than we expected it to do. Now moving into Capital Flats, the third system here, and this was like now a next level or phase where it was a project that Onion Flats was going to own and maintain as be a landlord for tenants on this project, which is always a good thing when a developer does that, because they're even more assured to make sure that these systems are designed well and operate properly. Now this is a pretty unique system. It's a 4-story, about 25 unit apartment building, and it had ground source or geothermal heat pumps, where it was open well going down into the Delaware River, pulling up the water from the river basically into a for the heat pump HVAC system, and then that would circulate into a heat pump water heating structure system as well for domestic water heating. And so any discharge water would go through that first, or water that came up through the river would go through that first. So it was really very efficient with for utilizing that heat, if you will, heat or cool, if you will, that was used for hot water. This also had a lot of monitoring all about, and in this particular case, we used bifacial modules. Bifacial modules are such that they're frameless, first off, and that they have a solar cell on the back side as well as the front side. And there's a little bit of maybe, it depends, I've heard and seen different studies, maybe another 5 to possibly 10% additional solar gain coming from diffuse radiation from the back. So this was how this all looked. And what happened here too was, when Tim McDonald wanted to do this project, we were initially planning to have a ballasted roof PV system on top of this flat roof. And I was just basically saying, that there's no way you're going to get really much of any generation. I mean, you get a fair amount of generation, but nowhere near that what he was hoping to get, because of all the setback requirements that you'd have against the edges of the roof there. And I said, you'll get much more if you could just raise it up off the roof. And he said, okay, done. And I was like, wow, this is after the building was already being constructed. If I recall properly, he changed how the whole top of the roof structure was going to be built. And therefore, he basically started to, it was redesigned to have these columns placed going up and making about 8 foot above, and placing the entire array on top of that roof structure, which is great. By the way, I want to point out here, I won't talk about it too much, but there are LED lights in all these little white sections over here. And these were, I'll try to remember talk about this later. This was used for behavior modification. There would be LED lights that would basically be shining either red, yellow, or green, and it would represent a given apartment, not necessarily the apartment that was that it was nearby. In fact, it would be an apartment anywhere else. It was basically keeping it anonymous of whose it was, but it would reflect the fact that that particular apartment was either being very energy efficient or not. It was based on their how their electric usage was going. And we are in the process of finally working on this. It's been several years after the fact, and the LEDs were in fact not wired properly. I have to go back, in fact, rewire all of these things. I didn't do the wiring originally, but it turns out that they all have to be rewired, and I'm stuck with having to do that. So we are going to be using this monitoring information, energy monitoring information, to determine what those what the color lights will be, and the algorithms for doing that. I wanted to show again these pillars that were kind of constructed here, and what was how it was structured over here. So here's the bottom of that pillar, and it goes all the way down, all 4 floors. It's on top of the studs, if you will, pack studs. I'm sure there's more of a correct terminology here, but just to say that there's no question that it's very stable in terms of its structure. So it was a really cool detail I had noticed and got confirmed on how that was done. This is what's called a string map. This is for the solar. This is the south, the north side, and this is the south side. And basically, the string is, you can see all these little rectangles here are each of the solar panels, and they're wired in series. So I think there's 14 of them in series, and that's going to be string 1, string 2, whatever. And each of these here are the inverters. The inverters are actually mounted over here, but this is more for the diagram. Each inverter, they're all the same size inverters, and they each take 3 strings. And it was really just to lay this out and see and to know how that's all going to be put together. Now, this particular system has a SolarEdge inverter system, whereby they use DC optimizers. And you may have heard of microinverters that are out there too. Microinverters are such that you can actually you plug the solar panel into a microinverter. Right there, you have AC. So these generate DC, turns right immediately to AC, and that's already going down into a distribution panel and tying to the grid. With DC optimizers, it's a similar type of thing, but they tie into the SolarEdge inverter. It's still a very efficient system, but that you're able to, each module is really working independently. So if you shaded one on one of the modules, the rest of the string will still operate properly. It's also valuable from executing what's called rapid shutdown, as required by National Electric Code 2017 and as well as 2014 for that matter. So that if the grid goes down, these high voltage, the high voltage of this solar array will come down to a lower, below risk voltage level, because even if the grid, and normally if you have a regular string inverter, if the grid goes down, this is still basically hot. If the sun is shining on them, it's a high voltage. You could be up to 5, 6, even 700, depending on what you're talking about volts. So it can be of a high risk situation. These types of DC optimizers and SolarEdge design will shut this down immediately down to a safe voltage level. So here's again the roof where we have the solar modules stacked up. You can see they're frameless, they're all kind of ready to go. Here is the rail that we were going to be putting up, and there's a standoff. So here's the tilt. It's about a 40-degree tilt. It's not very much of a tilt there, and that's basically the structure. And there's a and hopefully we can see a little bit better on how you'll see how the modules are attached to that. You can see over here how these clamps work. So we used, in this case, I think we used carriage bolts. You could also use what's called T-bolts that will drop into the channel of those rails. And then you tighten this clamp around the glass. So it's really a kind of a pressure way of holding that panel in place. And these are not wired yet, but you can see all the loose wires before we start to install the DC optimizers. Here's a close-up of the standoff that's mounted onto the beam, and then it's going down to the next one. And so there's a lot of open diffuse radiation coming into here that's shining onto the green roof. This happens to be all the inverters are down at the south end of the roof. So as you're walking down, it shows you how those strings were laid out. All these wires are being collected, and they're running down this little trough here, or down towards where the inverters are going. So as you're going closer and closer to the south, you're accumulating more and more of these wires. This is where the inverters are in fact located. There's 5 of them, and there's a distribution panel that has the overcurrent protection devices, or the circuit breakers for each of these inverters. And then this is a zigzag transformer that's used as required for the interconnection for the utility. And then this is a gross solar generation meter showing the gross amount of generation that is provided by the system. And here's finally a little bit more of the green roof. After some time, it's been growing pretty well. These are some ERV, HRV units over here. Yeah, so it's a really pretty nice. In fact, it's great. When I go there, and I'm always into hanging out up there. It's like nobody's ever there, so it's a really very tranquil place. And you can see it towering over I don't know how, I'll tell you this, I'm not sure how the city even, they never said boo about this. I mean, I would think this is kind of a little bit of violation, who knows? But anyway, it's great that it kind of hangs out a little bit over the area. This is the parking area. There's 13 slots in this area here. And this was after a lot of this stuff was already done. Tim had gone further with why this project is actually called the battery. And I never liked that terminology because there was never any battery storage there, but he did have something in mind about that. And these are EV chargers that were installed about a couple years ago. And his idea about it is to have leaf battery EV cars that would be possibly used for tenants to use, but some of them would be used for basically discharging into the building. So this is maybe down in the future if we can really get to that point, but at least he's got these chargers installed. He got a grant for doing that. Oh, good. Okay, I thought you meant I have 1 minute left. Okay. Okay, so yeah, so this is an interesting thing. We have yet to really figure out how this is all going to be working, but at least he got the chargers in place. This is the monitoring, some of the monitoring stuff that I that I did. So here are down here in the big box is the CTs that are placed for the solar part. This is where the solar is coming in, and we have the CTs that are connected to that, collecting that data. Over here are the CTs and the meters collecting that data for the residential apartment units. That's over down here. These are the circuit breakers on the feeders for all those apartment electric panels for the apartments. And then there's a whole other area for other types of equipment too. So this you can see the mass of all this wiring that has to come together and go into the monitoring system. And this is ultimately what came out of that. So for the first 3 projects and the monitoring, we used PowerWise for that. In this very last one, which we're about to go into with front flats, we end up using eGauge as a different monitoring system. But this is the kind of thing that we would see, and this is kind of showing September. This is the gross usage or power that you can see from the building that's being consumed. And then of course the solar that's we've got a really nice day here. And it's always an exportation or exporting of power on these days. Now, what's interesting about this, we just recently this is in Pico territory near Philadelphia, and they just started in time of use rate, and I'm very interested to see how this might work with changing this to time of use. The time of use is different from a flat rate where it's X amount of cents per kWh for the 24/7. Time of use rate allows for very high cost, very high rates for peak periods. And then you have an off-peak period at a much lower rate, and then a super off-peak period. And I think because this load shape is relatively flat, and because there's a lot of solar that's generated during that peak period, this could actually improve the economics of utilizing solar under that kind of rate structure. Down below here is I only had 2020 data to really put out here because we are having some problems with some of the monitoring right now, but here it ultimately is coming down to that about 57% of the electric usage is being offset by solar. And you can kind of see where, like here, June got 100%. The solar met all of June's electric needs or usage, and you can see where on the shoulder months like April and May, and then in September, you can see that's where you're getting quite a bit of solar because the HVAC system is not being used as much. And then this is sort of that last scene of how beautiful this is. It's quite amazing. I've seen lots of mushrooms growing, all kinds of wild stuff growing up here. Okay, so I'm going to move quickly to, how's my time? My time's okay? I don't know.
Yeah, you're doing great on time. It's
okay.
You've got at least another 10 minutes, so take your time.
Okay, so front flats, our last project here, and of course, Tim never ceases to amaze me where he says, okay, now he was very frustrated with the fact that that last project wasn't going to produce enough solar to offset all of the usage of the building. So he said, okay, fine, let's put it on three sides of the building as well as on top of the roof. So the east, west, and south walls. So, okay, fine. So that's what he wanted to do. And that's why I love working with this guy, because he's, he's going way beyond. I could never sell this concept to anybody. So when the developer and the architect is asking me to design the stuff for him because he wants that, that's fantastic. So anyway, this happens to be a 172 kW system. Same kind of bifacial modules. They're a different manufacturer. Solar edge inverters again. We're using DC optimizers, and it was intended to be net zero. I have to say, unfortunately, we're still having some issues where we didn't quite reach that net zero level. But it's a 28 unit system, a very efficient HVAC system that's being used in here, and let's see, ERVs, HRVs, the same type of thing that's being used for that too. Now, this was pretty cool. The left side, of course, is the actual project, but I happened to discover this rendering in my files today as I was putting this thing together. I was like, oh man, this is so cool. It's like, how could you get so lucky to have something that's so similar? So this was, of course, the rendering was done at least 2 years before the construction was happening. So you can see how similar it really came out to looking to the actual construction. It's kind of cool. Here's from a drone, a view of how it looks from the roof, over the roof. And you can see you don't have as much open air or open a space for for radiation to come in for that green roof. And I have to say, it probably will have an effect. It doesn't have as much solar radiation for enough maybe exposure for a green roof to really do well. So we have yet to really see how that works out. Right here is a train, the L that runs by here. So it's extremely close to where this is at. And you can see how the windows are all kind of where there are no solar modules, there are windows there, and that was really for exposure. This is the racking of the structures that Tim and where Onion Flats was developing as the building was being constructed. These are all welded aluminum structures that were going to be mounted onto the walls of the building, and then the rails were going to be mounted onto these, and then the solar panels are going to be mounted onto those. So here they're all stacked together. This is it being constructed right now, and I have to say, I would just wish I could document this stuff in sort of a very progressive time, but you get so swamped in being involved in the project, you forget to bring that camera along. But anyway, you can see how these are being mounted over here. And over here, the rails have been already mounted onto those support structures. And again, the important thing about this is these rails are intended for like on a tilt, like a 5, 10, 15, 25 degree tilt. They are not designed to be vertically positioned to hold solar modules. And I'll get into this a little bit more later on and how this was a concerning thing for me, but we were able to secure it and make it work. So but that was how this was kind of put together. And here is looking down the south wall, and you can see how they're mounted right up. These were amazingly stable. I mean, we were walking all inside here and it didn't budge at all. It's very, very secure. So here's the rail coming up. And then this is the intersection of that vertical and horizontal rail that going onto the roof, just to show that detail. There was a great architect working with Onion Flats that was helping me out with doing all these great drawings for me to then hand over to some of the labor folks in Onion Flats to install a lot of the different equipment that was needed. In this particular case, this was the west wall, and here you can see the rails are shown in here, the vertical lines, and that also there are the solar modules, the little rectangular shaped things there. And the intent here was to place these DC optimizers, mount them onto the rails before we put the solar modules on, because the modules are the last thing to be placed, and those optimizers had to be located properly in order to put these rails, to put the solar panels in. So here are the dimensions of exactly where these things had to go, and they were placed in those exact locations all the time. So these labor guys, they're just amazing. They always did such great work on this. This was a drawing, another drawing that I kind of came up with that was also constructed for me, but it really kind of laid out a much more detailed kind of layout here, which is, boy, come on, give me that cursor. There we go. Okay, so this is kind of showing, again, here's the solar module, for example. Here are the rails. You can see the rails of the vertical. And solar module, of course, has a junction box which has whips, has two wires about 2.5 feet long or so, the plus and the minus. And in this case, what they do, they plug into the optimizer. These optimizers, these particular optimizers would take 2 solar modules each. So instead of it being 1-to-1, it was 2 modules per optimizer. So it was very important to position these modules so that they were close to an optimizer. And you can see, like over here, this would be the junction box for this one. That would go to this optimizer. So it was really important how these things were laid out and how close those optimizers had to be placed on these rails. And then these are the strings. Now it's the optimizers that are actually tied together. So the modules tied to the optimizers, and then there's wires from the optimizers that go to each optimizer. So here's a string that goes all the way down and back up again. And that's going to be the plus and the minus of that particular string. And then that goes off to the inverter. So each inverter had 3 strings, and this is kind of like how it's laid out. And here's like a code I use for all kind of the structure and how I kind of put this together. I have to say, this all went like exactly as planned. It was really pretty phenomenal. A few little glitches, but no problem. We were able to straighten that out all the time. So I kind of would take those drawings and I placed them on the wall. So we got the east, the west, the south wall, and the canopy all up in the wall, so we can keep track of what was going on at all times. This is the optimizer I was talking about, where you can see there's 4 wires over here, and these 4 wires are 2 of which go to the one solar panel, 2 of which go to the other solar panel. So you got a plus and minus from one solar panel going in, plus and minus going from the other solar panel going in. And then this is the wire that comes from the optimizer and connects to another optimizer. So it's the optimizers that are actually really being connected to each other. Now, this is where it comes down to my concern about I was concerned about these possibly sliding down. The way this was pressure mounted, holding the modules up against the rail, I was very concerned that there could be, over time, some things could loosen up and possible gravity starts to pull stuff down. I don't know. So I was able to come up with using, sorry about that phone ringing, can't stop that. I was able to get around to using these we came up with 2 by 2 inch square aluminum plates that we're able to mount that just perfectly fit right underneath the solar module, which was fantastic. It blew me away that it just perfectly matched. So we screwed those in underneath every single clamp. And that obviously would hold that in place. It would never slide down at all. And you could see that that's where it is over here as well. It's kind of positioned right underneath that clamp. So that was made me sleep at night. So here we start now mounting the solar modules. And I have to say they were mounted and dismounted a couple of times because it was a learning curve. They maybe weren't lining up right to the left and the right. And over time, we got it all straightened out. And here's Tim actually at work. He's not sitting at his desk drawing. He's actually there doing some of that drilling right there. And we're mounting up all the solar panels. We're trying to get this corner just right, because it all came down to getting everything just perfectly in alignment. Now we're on the roof, and here are the rails going along the roof, and these guys are mounting this up here. Again, here are the clamps. This is the completed south wall at this point, and just wanted to kind of show how these looked underneath the, boy, I can't get this thing to work here. Oh well, anyway, so that's how you can see the structure, and this is actually showing a little bit more of that structure here, looking down. We're looking down from the 4th floor down, and again, there's actually my foot, or maybe it's, yeah, I think it's my foot. You're able to walk in this stuff. It was really awesome to be able to walk here and feeling perfectly safe doing so. This is looking to the side, looking across the wall, and you can see how far out these solar modules were and where that structure is all being connected up against the wall. This is, again, green roof is being prepared. They're doing some of the work and getting it in place. And you can see the solar modules here in this location, as well as on the roof. And all the wiring for all those four sides, that's the east, west, and south, and canopy, are all now coming together, converging over here on this left slide here, or left picture. And we're finally getting it to, they're all getting, and of course you have to keep very close track of what these are all the string wires that I was showing you before. Now they're coming into the conduit, and the inverters are in fact right against that wall right there. And here are the inverters, all 5 of them. And that here's the distribution panel where the breakers are for each of these inverters. And this is at 480 volts. This now goes down. We're on the roof, of course. At this point, we're going down all the way down to the basement. And here it's coming in at this disconnect, a fuse disconnect at 480, goes into a transformer, an isolation transformer, and a step down transformer down to 208, which is going now into this DC disconnect, AC disconnect rather. And then that's finally going into interconnection point on the service. This happens to be that not patio. Let me think of here. Little section I was pointing out before. Here's some water, a little waterfall that's running down here, and that was designed. It's working very nicely. Top view of poking my head through one of the openings on the roof, seeing some of Philadelphia. And here's the monitoring system that was doing here. That's again using e-gauge at this point. And here's, so the meter is up, one of the meters are over here. This is the commercial panel, which has some of the hot water, the heat pump water heaters. There's 8 heat pump water heaters for here. And those were to be used, or we were trying to separate the residential from the commercial, because what Onion Flats did was, again, multi-use building. Part of this building, Onion Flats moved into, and is now some of their commercial space. So we're trying to separate out the residential versus the commercial part of it. So that was done here. This is part of the residential circuit breakers and the feeders for that. So CTs were on that, and same thing over here, more of those apartment buildings with the CTs on, all of that. There's another monitoring system there. And this is kind of a, not bother getting to this, but this is like kind of, the table of mapping all that stuff, keeping track of everything. And here is, I'm very close to that. I think it's the last slide here. This is the monitoring system that it shows. This is, again, e-gauge, and 3 days that we're showing of its generation. Again, a relatively flat load shape, I'd say. And on good days, we're doing almost 100 kW, 90. I've seen over 100 kW that's being generated. Again, this is the gross usage. It's not the net. And then this is kind of demonstrating the amount of monthly solar generation every month, and it's being compared to PV watts, what was simulated originally. So the yellow is what was simulated, basically using 30-year typical weather data. And then next to that is, in fact, what is coming out from 2020 and 2021. Now, 2020 was a very bad year for solar. There wasn't as much insolation, so that there wasn't as good performance. But I will say that we are slightly underperforming what we're expecting to do, and I do have to investigate this a little bit more. The problem with data is that there's a lot of work that has to be done to follow up with it. So this is the final shot, I think, of that drone taking all different views of the front flats project. It's Darth Vader-ish, isn't it? That's about it. Not the last slide is really my, about me, but you know all about me, so that's good enough.